Welcome to today's webinar, everybody. I'm Dan. I'm a senior researcher at Aquafix.
And I'm Tyler Benz. I'm one of the technical service reps here at Aquafix.
Yep. And today we're going to be talking about reducing sludge and improving effluent quality in lagoon systems. Throughout the presentation, you'll notice there's a little bit of an area next to the chat box on the top right where you'll see polls and handouts. The handouts are provided and listed here. You can click on the handouts tab and download them at any time during the webinar. If there's any literature we discuss that you would like after the webinar, you can also feel free to email and reach out and we can get you everything there. We will also have a couple polls posted throughout the webinar, so just feel free to answer those and then you'll have to click to get back to chat. All right, so like I said, I'm a senior researcher. I've been working with Aquafix Laboratories for about 10 years. We do a lot of customer consultation. We do a lot of microscopy work, particularly for activated sludge systems. I've done a number of treatability style studies where we've set up like a mock lagoon or pond system and tried to see how some of our products work in that case. We do a lot of consultation and study work, and we also do research and development of products. All right, so today we're going to be talking about types of lagoons, things that would lead to and cause sludge accumulation and how that process generally goes down and then associated problems with it. We're also going to touch a little bit on algae and aquatic plants, our development of specifically our Sludge Rx product. We have a lot of interesting tests we've had to run to get that product working as intended. And then Tyler is going to be talking more about treatments for lagoons, including a number of our lagoon-related products and some case studies where we've used these products in practice to see how the results work. All right, so these are the types of lagoons we typically work with. We have our anaerobic covered lagoon. It's not going to really be the focus of today's presentation because in most ways they operate more like an anaerobic digester than a typical lagoon system. So we're going to be focusing more on uncovered lagoons, generally on the aerobic side, including an aerated lagoon, a fully mixed lagoon, and all of this stuff is pretty relevant to unmixed lagoons as well, unless they have some sort of like cover or layer on the top of them. Here's the pros and cons of aerobic lagoons. The pros are fairly simple. They don't require a lot of micromanagement in most cases. They tend to operate consistently. The bacteria do a good job removing nutrients. And it's a similar process to a standard activated sludge system. There's just a little bit less mixing going on, so it tends to be less efficient. But you have a similar system with the benefits of not having a lot of micromanaging to do. The cons, however, are it is very difficult to have a well-mixed lagoon. Most lagoons have primarily surface aeration. Particularly lagoons that are a little on the deeper side aren't going to have hardly any agitation below the surface layer, which means most of the bacteria that are being grown in the lagoon are going to settle to the base of the lagoon and begin to accumulate and produce a sludge layer. Sludge accumulation, therefore, occurs frequently in these cases. Also, reduced mixing means bacteria aren't able to come in contact with substrate nearly as easily, reducing the efficiency of the process and requiring higher HRTs. You also don't have floc as prevalently to work with, which means bacteria such as nitrifiers, which don't do well on the bottom of a lagoon, tend to not to have a lot of good surface area to adhere to. So it's a little bit difficult to maintain a population of nitrifiers. All right, so how does the sludge accumulate in lagoons? I touched a little bit on this before, but basically when the bacteria are given food, they start to produce biomass. This is essentially the exact same process as in an activated sludge system, and you're working with very similar environmental bacterial strains. So the bacteria eat the food, they begin to form little clusters, and then they sink to the bottom of the lagoon and they start to accumulate over time. And that's how the lagoon is working. These bacteria are taking the nutrients with them as they settle downward to allow the effluent quality in the lagoon to be improved. While this is occurring and producing a sludge layer, which is high in volatile solids, inert material such as sand and grit can also wash into lagoons through runoff, INI, that sort of thing. And you can also have, this is fairly big, you have a lot of leaf litter and shoreline plants making it into the pond. Leaves in particular take a long time to degrade, and they tend to trap gas bubbles under the leaves, which tends to puff up the sludge layer, and it can reduce the total volume of your pond that way over time just because you have stuff trapped in the bottom of the pond. So what impact does this have on the process? Nutrient release is a big one for sediments accumulating in a lagoon or pond. Essentially, all of these nutrients are going down to the base of the pond, and as long as that remains undisturbed, these nutrients will slowly diffuse up from the bottom and contribute to the nutrient loading in the pond. The nutrients that are being released are primarily going to be high in nitrogen and phosphorus because most of the sediments underneath the very thin surface layer at the top of the muck are going to be performing anaerobic digestion, which tends to have a high carbon demand relative to nitrogen and phosphorus compared to an aerobic process. So you have phosphate and ammonia being leached up slowly from the bottom sediments. But if the sediments are disturbed, the tendency is a lot of nutrients to be released in a short time. This can happen during turnover, during cleanings, that kind of thing. It can be a big headache and lead to a lot of algae growth because, like I said, this is high in nitrogen and phosphorus. The tendency is algae in plants are favored in systems that have lower levels of organic carbon. So if you have low carbon and very high levels of ammonia and phosphate, you get algae blooms occurring, which are usually planktonic and can lead to poor TSS levels in the lagoon effluent. The other thing is, as the sludge accumulates in a lagoon, we tend to see a phenomenon called channeling occur, where you have sludge accumulate along the sides of the pond, and you end up with a narrow channel going straight from the inflow to the outflow of the lagoon or pond. And therefore, you're dramatically reducing the hydraulic detention time because the water won't really spread out that's entering the system. It'll just go straight down the narrow channel and out the back end of the lagoon. Odor concerns are another thing that can happen due to sludge accumulation, particularly if the sludge is disturbed, but you have a big anaerobic layer and that can tend to be pretty stinky. You often have sulfur-reducing bacteria and things down there, which would be leading to most of these odors. I noticed we have a couple questions in the chat. First one's from Ethan, which is, my lagoon is unaerated. Should I add aerators? Are there any alternatives? That depends. I would say if your lagoon is operating fine, then the addition of aerators might not be necessary. The tendency is aeration systems don't do an amazing job mixing lagoons, so they are good to have to supplement some oxygen. But in a lot of cases, as long as your lagoon is receiving fairly low loading, it's not that big a deal one way or another. So that'll be a little bit dependent on your lagoon. The next one is from Jason, which I have sludge buildup in my covered lagoon. How can I break this down and keep it from coming back? That can be a challenge. So I assume this covered lagoon is a covered intentionally anaerobic system, and in these cases it's very difficult to do much about it. Like, once in a while they need to be cleaned out. A lot of the treatments you do for sludge reduction tend to focus more on aerobic systems, but Tyler will talk a little bit more about products which could be potentially used in this application to break down covered lagoon sludge.
Yeah, and without going too far off topic here, really with anaerobic lagoons, we'd look at more so degrading the substrate rather than using something like our sludge reduction products, just because with Sludge Rx, our sludge reduction product, typically it does require oxygen within the system. So we're pretty much limited when it gets to anaerobic lagoons, in that we focus more so on either degrading the fats or the proteins within it. And real quick, before we move on to the next slide here, just wanted to add on to Dan's point here of the increase in algae in aquatic plants with poor TSS. Additionally, they can also lead to spikes in pH. A good rule of thumb, if you are at all concerned if there is an algae bloom in your lagoon, frankly, most will have it. It's good to measure your pH in both the daytime and nighttime and compare the two. The bigger the discrepancy, or bigger the difference between the two measurements, will tell you really the degree of how much the algae is affecting or how much algae is blooming within it. And in some cases, it doesn't even have to have that greenish hue that algae typically presents. There are some transparent planktonic algae as well that can lead to that. So just one thing to watch out for.
Yeah, and the general reason that happens is that we'll see algae are going to be removing carbonic acid from the water body as a feed substrate. They use it to metabolize sugar or glucose to produce more biomass and have biological activities take place. And when they do that, they're going to be elevating the pond pH, basically. Okay, we have another question here, a couple more questions. One is, how do you prevent channeling in a lagoon? Generally, channeling occurs when there's a direct route through the lagoon and there's relatively fast flow through, is when the channeling tends to be the most prevalent. Generally, mixing and managing the sludge over time. We have some products which can help with this thing, which Tyler will again be discussing a bit more in depth later. But you can manage the sludge. You could physically remove it. You could treat it with a bacterial product. But generally, if you want it to not happen at all, it's going to be involving increasing mixing and agitation throughout your lagoon, particularly looking at things like bottom diffusion of air rather than a surface blower. One more question before we keep going here. How do you tell when the sludge depth is thick enough to be dredged? That's going to be mostly when your lagoon starts to be failing to meet effluent quality requirements, and you can track that and make a general trend. I would say if you're losing 30% of your lagoon water body, if you have a lagoon with fairly high loading, you'll start to see problems in effluent quality. If you have a really low loading lagoon system, it might be able to continue to function for much longer, and you might even see like 50 or 60% of the lagoon being filled up with sludge before you end up really needing to dredge it. So that's going to be dependent on your system a bit as well. But I would say on average, if you're losing about 30% of your pond volume, you're going to want to consider dredging. All right, so dredging for sediment reduction. I'm talking about this in this slide, so cover it a bit more. Every single pond or lagoon is going to require dredging to occur eventually once we reach the 30% threshold we're talking about, or once you start to see the pond is failing to meet its effluent specifications, then you're going to need to start looking into dredging. But generally speaking, when we're talking about the mechanical view of mechanical dredging process, it is very effective at preventing channeling, and it has a lot of potential to reduce future risk of nutrient release from the sediment layer, and it can remove some of the inert materials as well, which accumulate, which a biological treatment can't touch on inert materials. But while it is ongoing, it stirs up the sludge layer pretty extensively, which means it leads to a short-term increase of nutrients. You're also going to have more particulates in a lot of cases, which means we'll see higher TSS in lagoons effluent. And once in a while, you have a site where you have to warn about harmful material like metals or that kind of thing being trapped under the lagoon layer. Remember, when you're dredging, and I'll talk about this a bit more in a couple slides, but you have a layer of bacteria on the surface of your sludge, which produces a biofilm and stabilizes the sediments. When you're dredging, you are disrupting that layer, which means everything below the surface layer has more potential to be released into the pond. Of course, dredging is also expensive and labor intensive, and Tyler is going to talk about some case studies where we've dealt with dredging later on. All right, so the next thing I wanted to talk about was Sludge Rx development. So I talked about the pros and cons of dredging. Sludge Rx was developed to reduce the frequency dredging is required and provide a low-risk method for reducing the availability of nutrients in the bottom of the water body to help to improve effluent quality, make a more stable biofilm layer, and ideally reduce the volatile material in the sludge, because volatile material contains a lot of water. You end up with very high water content if you have higher volatiles, and that makes the sludge take up a lot more space than if it were converted to a less volatile material. So to do this, we had to develop a good setup to test ponds and lagoons for sludge reduction. And what we came up with was a method where we use 15-gallon fish tanks. We section 30 different squares where we take sediments tests throughout the course of the study, where we're looking at sediment thickness, and we're also measuring water quality throughout the duration of this test. It's kind of fun. Well, in some ways it's fun. You can see we're using a little plastic straw, which we put graduations on as a mini sludge judge. So we can take a little sludge from the bottom, see how deep the sludge layer is. There's a lot of modifications and development we had to go into this process. My colleague Deborah actually was working on this from like 2013 to like 2018, where she was just developing the methodology, because you can't just put some sludge in the bottom of a tank and put an aerator in and hope it will mimic a pond well. It doesn't consider wave motion. It doesn't consider the pond seal on the bottom of the pond. So we ended up with a method where we have aquarium pumps to produce a little more lateral movement in the water body to mimic something like wave motion, which run occasionally. We also have a sand layer covered up by a gravel layer and a clay layer to mimic more of a true pond seal on the base of our tank. And the sediments, we're just looking for the fluffy stuff that we can easily poke a straw through, and then we can gauge the sediment depth versus water column depth. And this study was run for about 4 weeks in most cases. It's a little bit variable depending on how much time we do have, because usually the tanks start in the spring and pretty much run all summer, and that's kind of what we got to work with. So it's a very slow process. But what we do get to see from this type of study is something like how the characterization of the sediments changes from the beginning to end of the study. At the beginning of the study, we have this sort of gelatinous sludge material, which is like a pudding consistency. And it was still pretty much that characteristic in the control tank at the end of the study. It was a little gelatinous. It was clearly holding a lot of water. If you were to dry it, you were seeing the percent solids was relatively low in the sediment layer. Whereas when we compare it to the Sludge Rx treatment, we were seeing the sediments became a lot more sandy and gritty, which signals that we're converting the nutrients into more non-volatile material, which is a little higher density. And the measurements there, we saw a decrease from about 7% volatiles total to about 5% volatiles total. So it was a measurable change in the sediment volatility, which leads to pretty large decreases in sludge volume in a lot of cases, because lower organic levels in the sediments mean you're going to hold a lot less water in the material, like I mentioned before. Get around to a couple questions here, since I see a number more have been asked. The most accurate way to do a sludge profile, that's a good one for right now. The key to doing an accurate sludge profile is to take more points. There is not a lot, it is not a very homogeneous layer at the bottom of the pond. If you're just sampling in 1 or 2 points, you're not going to get anything. Obviously, in our muck biotics test, 30 sections would be pretty excessive for a real pond. But if you're sampling at least like 6 or 8 sites spread out around the pond, you tend to get a pretty representative sampling. So in a lot of cases, what people do to do a really good job is they go out on a boat with a sludge judge, check 6 to 8 different spots, a little bit dependent on how big your pond is. If you have a very large pond, you might want a couple more points. If it's small, you might be able to make do with less.
And just to add on to that, so as Dan mentioned, one way to do it is just using a very standard, simple sludge judge. Another option I've seen a lot of operators moving towards is looking at sonar applications and doing sonar depth that way. Everything has its pros and cons to it. The biggest thing is that when you do measure it, and should you go through a treatment or you're just trying to track sludge levels over time, just make sure you're doing it in a consistent method. That's the biggest thing.
Yeah, if you have the availability of sonar, it is a nice way to take a look at the entire pond body, which is great. Obviously, it is also helpful to take samples throughout the pond, so we can be monitoring things like volatiles and non-volatile material and nutrient levels in the sediments. So a little bit of a combination of both methods is really best, but sonar gets you a really good picture. The sludge judging gets you a bit more of a sense of the sediment characteristics. All right, so continuing on the Sludge Rx studies, the goal with the product, like I said, was to be reducing sediments and also to improve stability of sediments. And one of the ways this works is it helps to produce a biofilm cap in the aerobic layer of the sediments, which prevents the release of nutrients from the bottom of the water body, because the tendency is sediments to have hundreds of times more nitrogen and phosphorus than the water column. And if that all comes up at once, you tend to get a lot of algae growth taking place. So while we're reducing the volatile solids over time, which, is like a 3-month process, we also want to keep the nutrients as fixed as possible below the sediment layer to reduce algal blooms in the meantime. Another note on the lab tanks. I said we did this study a bunch of times. The general tendency is with Sludge Rx, because of this biofilm layer, we tend to see a much clearer supernatant quality. The sediments are more stable and less is getting stirred up. So you can see with our Sludge Rx tank, you can actually see the aerator, which is kind of on the opposite end of the tank. The water is relatively clear. In our control tank, you can't really see it at all. And when we do these measurements, we're looking both for algae and bacteria. That's why we have our optical density at 580 and 681 nanometers. 580 tends to show more bacteria and 681 shows more algae. And basically, in both cases, we saw a better water clarity with the addition of Sludge Rx, and it was much better compared to the control. So we were reducing the amount of suspended algae in our test tank and the amount of suspended bacteria as well. So the other thing to consider is nutrients in the sediment layers. So we were monitoring total nitrogen and total phosphorus in the sediment layer. And this is a bit of a difficult area to quantify well. This is one of the reasons we needed to add the gravel and clay layer in the base of the pond. If you don't have that, the nutrients are going to be more likely to be forced upward into the water column if you don't have a real pond situation. So we were monitoring the total nitrogen and phosphorus, and we found they had decreased in the organic sediment layer. And that suggests, in this case, since the water quality nutrients were not higher, the nutrients were migrating downward to the sludge layer and contributing to the inorganic layer beneath the organic sediments. And finally, we did measure sludge reduction during these tests. In the case we're mentioning here, we saw a decrease from 2.1 inches in our Sludge Rx tank at the beginning of the study, all the way down to about 1.85 inches, as opposed to our control, which we were seeing was about 2 inches. And honestly, it pretty much stayed even throughout the course of the study. There was very little change. It might have puffed up a bit at the beginning and then went back to even. So you can see we have a clear reduction trend with Sludge Rx, and the control remains flat. And we were seeing, I would say, about a 10% increase in sediments in this case. But our volatile solids were somewhat low in this. You can see better results if you have higher levels of volatile solids, which we do frequently on the field. So to summary, the Sludge Rx product, is intended to reduce organics, which in the sludge, which compacts the sludge better. It prevents the release of nutrients and increases the time in between dredges you can get away with. It also creates a biofilm over the sludge that helps to lower TSS and stops resuspension of nutrients. And all this is working with aerobic bacteria with nutrients to help stimulate bacterial growth on the base of on the surface of the sediment layers, which is what's doing the work in converting the nutrients.
All right. Now that Dan has covered really the ins and outs of lagoon operation and the problems associated with it, along with the development of Sludge Rx, I'm here going to go into what Sludge Rx in fact is, as well as some other lagoon treatments for any type of wastewater lagoon system. So real quick, here is Sludge Rx, the product we've been referring to throughout most of this presentation. What it is a tablet consisting of both bacteria and nutrients specifically designed for sludge reduction. The nice part about it is it can really be used as either a target application or an overall general dose for your lagoon. Typically, when we go about using the Sludge Rx, we're going to recommend to use in the warmest months of the year, really just so that bacteria is going to be at its highest efficacy. For most systems, that's going to be roughly around April, May to about October, November or so, really obviously depending on what climate you're in. Furthermore, this is actually a case study. So taking what Dan did in the lab, Dan and Deborah did in the lab, and putting this to use out in the field. This is a study we did down in Pleasant Hope, Missouri. They were looking at potentially dredging the lagoon after the solids had accumulated pretty significantly in their wastewater lagoon. They were seeing about $300,000 plus in terms of having to dredge the lagoon, and they really did not want to have to spend that much money. So instead, they went and used our Sludge Rx product for about 3-4 months or so last summer. What they were able to see in doing so was about a 72% decrease in sludge levels in their largest lagoon, and just under that, about 68% or so sludge reduction in their smaller, about half the size of their lagoon. As you can see on the right, those are simply just their average sludge depth numbers in inches as we go throughout treatment. So you can see right there, it was a pretty significant reduction, thus saving them the $300,000 in dredging costs. Furthermore, in addition to our Sludge Rx, we also have the VitaStim Lagoon line. Very similar to it, except instead of a tableted form, the VitaStim Lagoon line products are going to come in bacterial packets, water-soluble packets. And really the advantage here is that these provide year-long treatment as opposed to the Sludge Rx where we'll use just in the summer months. Really the difference between all three is how the bacteria to nutrient content is ratioed. Most likely, VitaStim Polar is going to be more commonly used, especially in lagoons in the northern climates where temperatures don't quite reach peak efficacy for Sludge Rx, but you're still wanting to get good work performed out of your system. It's a great way to apply bacteria to the water column itself, whereas the Sludge Rx is working on the sludge layer specifically. So for those really looking to get ahead and get aggressive with treatment in the summer months, you can certainly use both to get full bottom to top treatment.
Yeah, and one thing I want to just interject here. I was talking about with the dredging process, you tend to stir up the sediment layer, which causes an initial release of nutrients. That's the kind of time when the lagoon line becomes a really good option because you have a lot of nutrients there for the lagoon line to work on. It tends to improve the efficacy of the lagoon line and prevent potential algal blooms, hopefully, if we're reducing the nutrients, but also improve lagoon effluent quality throughout the process.
And so, yeah, so to build upon that and add to the VitaStim Lagoon line, I see Jason here has a great question pertaining to this. What can I use during the colder season? Absolutely the VitaStim Polar. It's really, I always say, more bacteria means more work, especially in the colder months when bacteria tends to lose out on efficacy, even in some cases go completely dormant when the lagoon freezes over. Before it has frozen over or just after it thaws, VitaStim Polar is a great way to get as much bacteria into your system and start the process a whole lot sooner. Avoid that lagoon turnover in the spring, or at least mitigate its effects, and really get the ball rolling come summer. Yeah, and same thing to answer Chris's question here, except in the summer. Absolutely. So you can for sure treat with Sludge Rx during the summer months, get ahead and start reducing sludge that way. Additionally, once again, you can pair it with a VitaStim Lagoon line. Typically, as you can see there on the bottom left, this is going to be the temperature gradient for which product is going to be associated with what temperatures. It's not a hard set cutoff, but typically in the summer months, you're going to be looking at something like VitaStim Sludge Reducer, and in extreme weather, you're going to be looking at VitaStim Summer Slam. Once again, you can do that in addition with Sludge Rx. And looks like there's a couple more questions on Sludge Rx specifically, so I'll just head back there. We'll go to Ethan's question at the top. Where does all the sludge go when using Sludge Rx? Much like aerobic activated sludge wastewater treatment, where nutrients are coming in at large complex materials, that bacteria in those aeration basins or even in anaerobic systems, those bacteria are going to break it down into much smaller molecules. Same thing here with Sludge Rx and the VitaStim Lagoon line. Any of those complex nutrients and any that are ending up at the bottom, like as Dan said, any of the organic matter, plants, leaf, those will get broken down by the bacteria and not detect them out. So they will consume those nutrients, that nitrogen, phosphorus, carbon, you name it. And additionally, yeah, Ethan, another question here. How big/small of a lagoon can Sludge Rx treat? There's really no limit in either direction. Anywhere there is sludge accumulated, and as long as there's oxygen, organic matter, and proper pH, roughly neutral, Sludge Rx will in fact work on it, as long as you meet the dosing requirements.
Yeah, the only restriction there is if you have like a really large pond or lagoon, application can take a while at that point, but you can actually spot treat Sludge Rx in a number of cases if you want to focus on one zone of the pond or lagoon 1 year and then another zone another year.
Yeah.
Kind of thing.
So it's not really necessarily a product limitation. It's more so just an application limitation. What is the cost per treated lagoon/sludge volume? So it's going to be tricky. I would like to definitely see the numbers. And Nell, if you want to reach out to one of our technical reps, including myself, we'd be happy to get into more specifics. Typically, we do about 60 pounds per acre of Sludge Rx treatment, roughly about at least 3 months. The more months we can cover, the better. So typically we try to aim for at least about 4, maybe 5 months even, depending on your climate and where you're located. Oh, another question here with Sludge Rx. So we use Sludge Rx for many years now, and it has been working well. Will it continue to break down sludge year after year, or is there a limit where it'll stop working on the same sludge? It really comes down to, as Dan said, total volatile solids. If you're able to reduce all the organic matter in your lagoon, which would take a long time and a lot of bacteria, but it is certainly doable. You can get to a point where maybe it is just sand, gravel, or any of the insoluble inorganic matter on the bottom of the lagoon. In that case, it would be something to look for, trying to get your sludge analyzed, and knowing your total volatile solids percentage will help kind of understand how much more can be done by Sludge Rx or any other added bacterial.
Yeah, the tendency is just over time, you end up with a lot of sludge with relatively low volatile content. And that's where you end up, you eventually do still likely need to dredge. It just hopefully can extend your time substantially beyond where you would normally have to dredge without the use of the product.
Oh, and I guess to build off that, so Chase, yeah, definitely looking at total solids and total volatile solids. So to answer Jason's question, how would you test for total solids and total volatile solids?
There's a standard method for wastewater, which you would use an oven and a furnace. Basically, total solids, you're just going to dry out the sludge sample. You got to do that at about 104 degrees for usually you do 24 hours and put the sludge in a crucible. I'd recommend reading up on this because I'm not going to describe the method perfectly for everybody to follow right now. But then you'll put it in a furnace to burn off all the organic material, and then you'll compare the dry solids mass to the ashed solids mass, and you can get the solids. You can also you can send this out to a bunch of different labs, and they'll be able to do the testing. It's a pretty standard test.
What is a good DO to have in a lagoon? Really, in most cases, in most aerobics, really any sort of wastewater treatment processes, typically 2 to 3 parts per million is going to be typically what we recommend. There have been quite a few instances where you can work well around that range. It's really going to come down to how well your system has been operating at your current DO levels. Obviously, you can look at in an activated sludge system, you can look at, do you have low DO filaments or anything like that? In a lagoon, it gets a little more trickier. But as long as it is an open air lagoon, or even more so if you do have aeration, probably very unlikely you're going to have low DO unless you do have very large sludge accumulations.
I want to add, there is a tendency in lagoons for people to not measure at a representative point when they're taking DO measurements. So if you measure it near the surface where you have surface aerators going, you tend to measure pretty high DO levels. You might see a DO of 6 at that point in the lagoon or pond. But then if you were to drop a DO probe down to a foot above the sediment layer, you may have nearly nothing there. And that isn't necessarily a problem if the lagoon is still meeting its effluent requirements well, but it is something, the more anaerobic the sediment layer tends to be, the more likely it is to leach nutrients slowly into the surface of the pond, which can cause, effluent issues and that kind of thing.
So once again, there's the VitaStim Lagoon line. And as you can see, there's that temperature breakdown on the bottom, just for those of you who are interested. And once again, if you ever need any sort of recommendations, you're more than welcome to reach out either to myself or any of our other reps here at Aquafix. Furthermore, another companion product and treatment for really both the Sludge Rx and VitaStim Lagoon line is the OxyPaks XL. So actually kind of going back to the DO question, when you do have a large sludge accumulation and you do have it compacting pretty tightly, it can get pretty difficult for any aerobic bacteria to access. So oftentimes we look at using something like OxyPaks here, where it releases hydrogen peroxide in that sludge layer, very similar to aerating your lawn. It's going to release a good amount of that sludge, or at least free up a lot of space so that that bacteria can get inside of that sludge and begin to work that way. Unlike dredging, it's not going to drastically pop up or lift up any of the sludge layers. It's just going to allow for a little bit more wiggle room, so to speak, for the bacteria to get into. Once again, great way to offset septic conditions if that is something where it is collapsing pretty heavily and very thick to where no oxygen can penetrate either way. And lastly, real quick, is just DAZZeL ECO. So we did mention high sludge accumulations can lead to odor issues, as well as just unmixed lagoons or unaerated lagoons can also pose the same issue. DAZZeL ECO is a very quick and easy product to use. What it is just an essential blend, or it's a concentrated blend of essential organic oils. All it is just an odor encapsulator. So just adding a little bit to the lagoon will help bring down odors and save you some complaints there. But really, Sludge Rx is something better to use, I would say, in the long run, because you're addressing the underlying cause. But DAZZeL ECO here, we like to have options. This is a very quick fix, especially for those, maybe it just happens once a week in August or so, warmer months. Great way to add a quick fix there. So that wraps up all of the products associated with lagoons. We'll head over here again to the questions. And if there's any that we happen to not answer today, please feel free once again, reach out and we'd be happy to answer those. So will Sludge Rx work in an unaerated lagoon? It will, as long as the lagoon itself is uncovered. So at least you do have some facultative conditions coming into the lagoon and there is at least some oxygen present. So once again, like Dan said, it's a good way. Make sure you're measuring DO in all sorts of places. Typically, you're not going to have severely low DO conditions in any of those types of lagoons to where Sludge Rx will not work at all. But it is good to be on top of it, be safe, and make sure you're measuring DO all throughout.
Yeah, that's also going to depend a little bit on the loading in your specific pond. We have a lot of industries which are discharging a ton of like really high strength waste into the pond. And in those cases, we would probably want to talk with you at least before we recommend the Sludge Rx treatment. But most lower loading lagoons are not going to have any problems as long as they're uncovered, like Tyler said.
And to build off Sludge Rx once more, got a question here from Todd. When the Sludge Rx digests and creates the floating poop, how long till the floating material goes away? Not sure. It sounds like you're referring to just pockets of settled sludge that have just broken away from the large accumulation in the sludge layer and had enough buoyancy to float up. It really is going to come down to the consistency of what organic material it actually is. Fats, oils, and greases will most often than not be the most likely sort of organic material to float to the top. So it's really going to depend on what that in fact is comprised of. But certainly if it does inevitably settle back down to the lagoon, it will be consumed in really, I'd say just a couple months of Sludge Rx treatment.
Yeah, if you have blobs of floating sludge coming up, a lot of the time that is also could be related to gas production in the sediment layer, which is very often nitrogen gas or carbon dioxide being produced. The Sludge Rx, we have not necessarily found to encourage this gas generation because it tends to work more on the surface layer, but it's possible it could hit the surface, and if you have really light floaty sediments, it could sink in a little bit, and then you might encourage a little bit of denitrification or carbon dioxide production through anaerobic digestion that way. If your lagoon is well mixed or somewhat aerated, I wouldn't expect it to stick around real long, but if it's an unmixed lagoon, it's hard to say, and we'd just like to talk with you about it if it's starting to be a problem.
So 2 algae questions here. I'll kind of read them all. I'll read both of them off and answer them collectively. So 2 years ago, I had our lagoons dredged. Prior to dredging, I had never had bad algae. Last year, the algae is bad. Why is that? And what is the best algae treatment, short-term and long-term? We have it every year. So 2 questions that really go very much hand in hand. So prior to dredging, they never had any sort of issues with algae, but take away all those biosolids, started to have issues. Why might that be?
I would say in most cases, when you are dredging, if you have a fairly thick nutrient-rich layer, you're going to be stirring up the sediments a little bit, which can release nutrients into the pond, which could contribute to the following year. I will caution a little bit, like there's a lot of different things which can lead to an increase in algal blooms in a pond in a specific year. I wouldn't always 100% attribute that to dredging, but in the case of you have dredging, which increases the nutrient loading in the pond, you'll likely see higher nutrient levels in your effluent, or if you were taking pond samples. In that case, I would probably recommend one of the bacterial products that we mentioned before for the water column to be able to control that in the short term to prevent it. It's kind of a nice follow-up to the dredging process.
Yeah, so to build off that, best course of action for algae, short term, you can look at something just like a simple copper algicide or herbicide. That's something we do provide. We didn't include it since we want to focus more so on sludge accumulation. But that's, once again, if you want to reach out, we can always talk further about that. But really the best is, it's always better to be proactive as opposed to reactive. So adding bacteria in the form of either Sludge Rx or the VitaStim Lagoon line to begin reducing as many nutrients as possible within the lagoon you will begin to mitigate those blooms over time.
Yeah, and to be clear, like if you have an algae growing, none of our products are going to kill it. You're going to reduce growth over time by reducing nutrients, but none of the products we're providing, other than things that are labeled as algicides, are going to harm the algae that is currently there. So in the short term, if you want to control it, you'll have to look for some conventional chemical algicide treatment. But the idea is to prevent the growth by reducing the sediments, and that tends to be an effective long-term solution like Tyler was talking about.
And looks like, oh, and to build off Chris's question once again, and duckweed too. So duckweed and algae, both while they're very different in structure, presence, that sort of thing, both are generated by, once again, a high nutrient loading inside a lagoon. Duckweed is going to have less so of an impact on really much of the effluent parameters except for TSS. When it does die off, you will have a pretty big spike in TSS. So it's best course of action to, number one, control it as best as possible, whether that's even physical removal or, once again, looking at something like an herbicide or algicide. Typically, they're actually great. Duckweed is a great sink of nutrients since they do grow off of nitrogen and phosphorus. They're actually really great at consuming it. It's only when they die off that it does pose an issue.
Yeah, they also block light, which can be a very effective control to other algae present in the pond. I would say, even going back to the algae question, like if the algae is influencing your effluent quality, if it's something that can float out and increase the TSS, if it's messing with the pH dramatically, that can influence effluent quality, that kind of thing, that's a problem. But things like attached algae growth tends to not be any issue as far as lagoon effluent quality. In fact, it tends to be more of a help, just like the duckweed. In the case of duckweed, a lot of the times the best course of action is just to like float some pool noodles around the outflow. It's not going to get under them. It'll just stay in your pond and then it won't influence the effluent quality. And it'll help to clean up nitrogen and phosphorus pretty effectively.
When running your studies, was the effluent TSS monitored and did it change during the study? I'm assuming this is referring back to the lab control Sludge Rx study.
We were monitoring optical density, which we mentioned in a slide. The tendency is our sample size tends to be a little bit of a higher error margin for TSS. We can't be taking, liters of sample out of the tank. Otherwise, we're promoting too much flow through that's not representative. But the optical density we were measuring was monitored, and it is actually looking for suspended bacteria and algae. And it was lower with the addition of the Sludge Rx specifically.
Sometimes in the summer, my effluent pH gets over 10, but it looks clear when I pull a sample. Once again, going back to, as I mentioned previously, with increasing algae and aquatic plants in lagoon systems, it will cause a pretty drastic difference in pH between day and night cycles. So if it's over 10, it's safe to assume that certainly there is some algae at play. But when it is clear, there are still some strains of algae that will still have an effect on pH. They may just not be visible to the eye. There are transparent planktonic algae strains out there. So that's one thing. If you're still seeing that pH difference, there is still reason to believe certainly that algae or any aquatic plants are the root cause.
Yeah, and the other thing to consider is you have a really large water body. You take a little small sample, there might not be very high levels of algae in the sample because they're spread out throughout the water body. Or you could have algae growing at the bottom of the pond, algae that's clustering in different sections of the pond. You can have planktonic algae that can swim away, and they aren't going to run away from you grabbing the sample, but they might just be in a different spot at the pond at that time when you're looking. There's a whole bunch of reasons why it wouldn't be in your sample grab.
And looks like we got 2 more nutrient questions here. So what are some of the cost-effective methods to reduce total nitrogen in Lagoon supernatant?
Cost-effective methods to reduce total nitrogen in Lagoon supernatant. This is going to be, I always go back to, it's going to be somewhat system dependent. What is causing the nitrogen loading primarily in your case is relevant. If you have a high incoming loading and you're getting decent removal, but not 100% removal, then something like a nitrifier product or one of our other bacterial products can potentially help. If you have relatively low nitrogen going into the system and nitrogen is relatively high in the effluent, the tendency is that nitrogen being released is being stored in a sediment layer in your pond or lagoon. So in those cases, you're best off focusing on the sediment layer in the lagoon. And things like nitrifiers are not going to help at all in those cases. It's not nitrogen that's coming in. It's stuff that's just slowly diffusing up from the pond. In fact, there's a surprising number of cases where people will have ammonia come in their pond at like 10 ppm and it'll be leaving at like 20 ppm. And in those cases, it is all just coming from the pond. It's been stored over time.
Are you stating that Sludge Rx removes phosphorus and nitrogen while eating up sludge? Wouldn't nitrogen and phosphorus be released similar to lysing a cell?
Sludge Rx isn't going to lyse any cells. One thing to consider is we looked through a lot of studies and did a lot of work with the rate of which that bacterial, like say you have a bacteria, it eats a bunch of nitrogen and phosphorus. It's sitting on the bottom of your pond. A lot of the nitrogen and phosphorus is going to be stored in the cell structures that are going to be prevalent for a long period of time. It often can take like 4 months for that bacterial cell to break down to the point where it's actually going to reduce any nutrients. And that happens very gradually. The other thing is the idea and what we were talking about with converting volatile materials to non-volatile materials is the nutrients will actually go down to the clay layer below the sediments and they'll begin to accumulate in inert inorganic forms. So that's a mineralization process rather than having it be actually consumed. And in that case, you're not going to be releasing more into the water column. But I don't want to be like super black and white here. For example, in our sludge tanks, if we added an excessive amount of sludge to them, we didn't have any clay or gravel layer on the bottom, you can make nutrients come up, especially if you were like overfeeding product, you had an excessive amount of sludge, you didn't have anywhere like a plastic liner in a pond. There's a bunch of different things to consider when asking that sort of question.
Will Sludge Rx work on any wastewater sludge anywhere with air then? Yeah, once again, so with any sort of wastewater lagoon system, as long as there's some oxygen present and a good amount of organic material, Sludge Rx will work. We have had some cases where we can use it in aeration basins. It does typically require somewhat of a longer retention time than most activated sludge processes, but it is doable. So to answer most question here, I have an aeration basin. How can I bring the MLSS concentration down, which is high at 9,800? So yeah, you can use Sludge Rx, but really the easiest practice is just going to be simply to waste heavier.
Yeah, I don't think the Sludge Rx in an aeration basin, we're talking about a suspended mixed liquor 9,800. I assume that is verified and you're grabbing it. Like, also, I'm assuming this is a conventional aeration basin. I've almost never heard of solids getting that high in a conventional aeration basin. Sometimes I'll see it with like NBDRs where you have a membrane to keep the sludge in the system. But yeah, if you're able to waste, definitely taking sludge off site to reduce the sludge in the population makes sense. But there have been some industries where you just have so much loading coming in that you're just trying to hold as many microbes as possible. So I guess if it still sounds pretty extreme, but if you have questions about the specific site and you have problems with wasting, feel free to reach out to us and we can discuss it further.
And it looks like we got all those questions answered. We're going to throw a couple polls in here just to kind of get a feel for everyone's opinions and kind of see what operators are doing out in the field. So the first one we'll throw in is, what type of lagoon do you have? Feel free to head over to the poll section just to the right of the chat section on your right-hand side and answer away. And just to clarify there, it says anaerobic open lagoon. It would just be a normal open lagoon, just unaerated.
Yeah.
So it should just be unaerated open lagoon to specify.
Yeah. All right, we got about half the population responding. Feel free to add a few more responses if you would like. It looks like we're seeing mostly open lagoons or aerated lagoons. Not seeing too many anaerobic covered lagoons in this. That's interesting. I would say if anybody's willing to comment in the chat as far as for the aerated lagoons, what sort of aeration is it? Is it dominantly surface aeration? Do you have many bottom diffusers? Just get kind of a sense of what type of aeration people are using on average. This sort of question helps us focus future webinars and some of our research and development. So it is really helpful to see what people are responding.
So first question going in right now is how often is your lagoon cleaned? So by clean, that could be dredging, any way, any mechanical way of sludge removal. And while you're still on the poll section, we'll also throw in how often do you do a sludge judge? Sludge profile. Going back to the second one we put in, how often is your lagoon cleaned? It looks like that one's slowed down quite a bit. Looks like a good majority is about either never or every 10 years, which is typically about what we'd see in the field. Going all the way back to the pros and cons of lagoons, they're really great that they can work for really honestly decades. Pretty minimal intervention needed until the time does come when you do need to in fact dredge. It's hard to gauge when that timing actually might be, but it's one of those things. It's never too early to get started on treating it so that you're not faced with hundreds of $1,000s or even millions to effectively get that sludge removed and moved elsewhere. Every 10 years, very similar. It seems like most municipalities that do have the ability to get it mechanically removed have a pretty good system in place to get it done at least somewhat routinely. And how often do you do a sludge judge? So yeah, annually, every few years, only when there are problems, and never. For those that have said never, definitely one of those things. You don't have to do it all too often, but it is good to have a pretty good sense. I would say annually to about every other year is going to be a pretty good time to do a sludge profile, just to keep an eye out and certainly make sure that you're not getting too much accumulation, and it'll give you a pretty good sense of when you can start to looking at future options.
Yeah, and the collecting of the data to see what rates the sludge is typically accumulating year to year is really helpful for planning for how frequently you're going to be needing to clean the pond. And since a lot of lagoons can get away with going, like Tyler was saying, over a decade without cleaning and still have it be fine, you can be borderlining having a big disaster occur with nutrients for years, and the lagoon will get by, and you might have an exceptionally warm summer. You might have higher flow through than normal, and it might stir everything up. There's a lot of things which can just hit you all of a sudden. If you don't have that data accumulated, you won't really know what to expect, and it can help forecast a little bit.
Oh, perfect. So Henry here has diffusers and surface aerators for aeration.
That's good. So you probably have one of the really well mixed lagoons.
Very good. Can you share your contact information? Yes. So right there, this is our contact information. So feel free if there's any other questions you have after the fact, after this presentation, or you're interested in anything else we talked about today, you're more than welcome to reach out. Once again, my name is Tyler Benz. I'm one of the technical service reps here. Chris Grove and Dalton McGowan are the other two. Feel free to head to teamaquafix.com. All of our information is up there. Otherwise, orders at Team Aquafix. My email is actually tyler.b@teamaquafix. Otherwise, feel free to give us a call anytime, Monday through Friday, 7:30 to 4 p.m. Our number right there is on the screen, and it could get you in touch with any of our reps here at Aquafix.
Yeah, and if you need any technical advice, I'm usually available for phone calls of that thing. Just reach out to our standard number. We can get somebody from the lab on the line to talk about some technical inquiries as well.
So thank you all for attending today's webinar. We will have a webinar coming up in about 2 months or so. So keep an eye out for that. Feel free to get signed up early on. As always, if someone may have missed this, or you want to go back and review this information once more. It will be archived in just a couple of weeks. We'll be sure to send out information on that. But thank you again. We appreciate it.